Hello viewers, in today's class we are going to discuss two very important problems from integration, right? And the first problem is given here, and here we have to evaluate this indefinite integral in which we have to integrate cos 8x plus 1 divided by tan 2x minus cot 2x, right? So let us start, and let us first call this integral as I, right? Now in order to solve these type of problems in which the integrand involves trigonometric functions, what we have to look for, we should go for the important identities, right? So here again we'll make use of some important trigonometric identities in order to integrate this function, right? So first we will try to simplify this expression, and we'll try to reduce this integral into a known form, right? So now here if we see in the numerator we have cos 8x plus 1, right? So we know from trigonometry that cos of 2 theta is equal to 2 cos square theta minus 1, right? So we have cos 2 theta is equal to 2 times cosine square theta minus 1, and now if we replace theta by 4x, then here we'll get cos of 8x, right? Which is right over here. So cos 8x is equal to 2 cos square 4x minus 1, right? So here if we take this negative sign to this to the left hand side, we'll get 1 plus cos 8x is equal to 2 cos square 4x, right? So now we will replace 1 plus cos 8x by 2 cos square 4x. Okay, now let us simplify this integral. So here we have 2 cos square 4x divided by tan 2x can be written as sin 2x divided by cos of 2x minus here we'll have cos of 2x divided by sine of 2x, right? So now we have this expression. So now let us first simplify the denominator. So we have 2 cos square 4x, and if we take the LCM, here we have cos 2x, then we have sine 2x, and sine 2x times sine 2x is sine square 2x minus cos 2x times cos 2x is cos square 2x, right? And now we can take this term to the numerator. So we have integral of 2 cos square 4x times cos of 2x sine 2x, and in the denominator we have sine square 2x minus cos square 2x, right? So now at this step we have to again take help of trigonometry, right? And see, here we have this 2, right? So if we take this 2 with the cos 2x sine 2x, then see what we will get. We have cos square 4x, and now we can take this 2 with this term, right? So we have 2 sine 2x and cos 2x, right? And in the denominator if we take the negative sign common, then we can take the negative sign outside the integral. So we have cos square 2x minus sine square 2x, right? So now from trigonometry we again have an important identity, that is sine 2 theta is equal to 2 sine theta cos theta, right? And now see, here we have this term. So if we replace theta by say 2x, then we have sine, here we have 2x, so this is 2 times 2x, so this is 4x, and here we have 2 sine 2x cos 2x, right? So now we can replace this term by sine 4x, right? And see, in the denominator we have cosine square 2x minus sine square 2x. So we again know that cos 2 theta is equal to cos square theta minus sine square theta, right? So this problem involves a lot of trigonometry, so we should know all these trigonometric identities to simplify this integral, right? So again we can replace theta by 2x, so we have cos of, here we have 2x, so this is 4x, and we have cos square 2x minus sine square 2x, right? So now this expression can be replaced by cosine of 4x. So now we can write this integral as minus integral of cosine square 4x. Then we have here sine of 4x. Then we have here cosine of 4x, right? And now this cosine 4x get cancelled, so here we are left with 1 cos 4x, so we have minus integral cos of 4x sine of 4x dx, right? So now we have to evaluate this one, right? So here we have I is equal to negative, and see, if we multiply this term with 2 and divide by 2, we can write it like this, half, and then we have 2 times cos of 4x and sine of 4x, right? So why we have multiplied and divided this term by 2? Because we know this identity, right? So sine 2 theta is equal to 2 sine theta cos theta, and see, if we replace this theta by 4x, then we'll get sine of 8x, right? Because here we'll have theta is equal to 4x, so sine 8x is equal to 2 sine, here theta is replaced by 4x, so we have 2 sine 4x and cos of 4x, right? So now this term can be replaced by sine of 8x, so we have minus half, and we have sine of 8x dx, right? So we have seen that how we have simplified this expression using all these trigonometric identities, right? And now this is a known integral, and we know that the integral of sine ax is equal to negative of 1 over a cosine of ax, right? So now we can write minus half, and here we have minus 1 over 8 cos of 8x, right? And c is the constant of integration. So we have minus minus plus, so we have 1 over 16, 2 times 8 is 16, so we have cos of 8x plus c, right? So the integral of this function is equal to 1 over 16 times cosine of 8x plus c, where c is the constant of integration, right? So let us take one more problem. So now let us take the second problem. So here we have to integrate this algebraic expression which looks quite bulky here, that is x square minus 1 divided by x square plus 1 times x raised to 4 plus 1, right? So in such type of integrals where we have a complex looking algebraic function as an integrand, what we usually do, we first try to observe the integral, right? So we first try to observe the given integrand, and we try to take some terms common out of the numerator and the denominator, right? So here we'll try to take x square common in the numerator and x square common in the denominator, right? So let us see how we can do this. So if we take x square common from the numerator, see what we will get. We'll get 1 minus 1 over x square, right? And in the denominator, what we will do, we'll take here x common, right? From this term we'll take x common, so we'll have x plus 1 over x, right? And in this term we'll take x square common, so what we will have, we'll have x square, then we'll have here x square plus 1 over x square, right? So now we can simplify this expression. So we have here x square 1 minus 1 over x square, and here we have x plus 1 over x, and from the square root we can take 1x outside, and that makes this x square, and here we have square root of x square plus 1 over x square, right? And now this x square and this x square get cancelled, and we have 1 minus 1 over x square divided by x plus 1 over x, and here we have x square plus 1 over x square, right? So why we have taken x common or x square common in the numerator, and x common from this term and x square common from this term, because see, if we now take this term as say t is equal to x plus 1 over x, then the derivative of this t is dt over dx, and the derivative of x is 1, and the derivative of 1 over x is minus 1 over x square, which is present in the numerator, right? So now we have dt is equal to 1 minus 1 over x square, and here we have dx, right? Okay, so now we have to substitute 1 minus x square dx as dt in the numerator, and x plus 1 over x as t in the denominator. But what about this term, right? See, here we have x square plus 1 over x square. So if we now take the square of both sides, what we will have, this is t square, and here we have x plus 1 over x square, right? And now the square of these two terms is x square plus 1 over x square, and then we have 2 times x multiplied by 1 over x, x and x get cancelled, so we are left with 2, right? So we have t square minus 2 is equal to x square plus 1 over x square, and the square root of x square plus 1 over x square is equal to square root of t square minus 2, right? So now this integral I in terms of t, it now reduces to here we have 1 minus 1 over x square dx. For this we can write dt, and in the denominator we have t, and for square root of x square plus 1 over x square we have square root of t square minus 2, which can also be written as square of square root of 2, right? And now in order to evaluate this integral, if we see the results for standard integrals, we see that the integral of 1 over x times x square minus a square is equal to 1 over a, and we have a secant inverse of x over a, right? So here we can now use the standard result. So here we have the integral in terms of t, and for a we have square root of 2, right? So the value of this integral from this formula is equal to 1 over a is the square root of 2, and we have secant inverse of x over a. So for x we have d, and for a we have square root of 2, and here we have plus c, right? And now we can replace this t by x plus 1 over x. So we have 1 over root 2 and secant inverse of 1 over root 2, and we have x plus 1 over x plus c, right? So this is the required integral of this function.